Hello and welcome to the Math Studio. In this video, we're going to derive the half angle formulae, also known as the t-formulae. Now, in a previous video, we looked at the double angle formula for tan of 2 alpha. And we could express that in terms of tan of alpha as 2 tan alpha over 1 minus tan squared alpha. So this is the double angle formula for tan. Now, if you look on the left-hand side, this angle is double this angle on the right-hand side. So it's clearly obvious that 2 alpha is double alpha. Let's say we halved the angle on the left-hand side. You would then have to halve the angle on the right-hand side for the equation to remain valid. So what we can say is that hence tan of alpha is equal to 2 tan of alpha over 2 over 1 minus tan squared alpha over 2 to remain consistent with the double angle formula. So technically speaking, both of these formulas are in fact identical. It's the double angle formula, but it's expressed a little bit differently. Instead of explicitly showing the double angle, we're just showing the angle on its own, and then in terms of the half angle. So to make it a little bit easier to write this algebraically, so we're going to let t equal tan alpha on 2. Therefore, tan of alpha is equal to 2t, since t is just tan alpha on 2, we can replace that out and substitute tan alpha on 2 for t, over 1 minus t squared. So that's the first of the 3 half angle formulae. Now we need to look at deriving the formula for sine of alpha and cos of alpha. But before we do that, let's think back to sort of fundamental right angle trigonometry. So tan of an angle, or tan of theta or alpha, whichever, tan of alpha or tan of anything is a ratio, or is the ratio, opposite over adjacent in a right angle triangle. Okay. So the opposite is 2t, or represented by 2t, and the adjacent side is represented by 1 minus t squared. So from that, we need to find the hypotenuse in terms of t. Now always remember t is tan of alpha on 2. But sometimes we forget that. But at least for the time being, it's convenient to just not think about it in terms of tan alpha on 2 and just think about it just in terms of t for now. So now we need to find the hypotenuse. Okay. So I'll just use a pronumeral for that. So let's call it x. Okay. So x is equal to the square root of 1 minus t squared, all squared, plus 2t, all squared. Okay, if we expand the brackets, let's see what we get. So 1 minus t squared, all squared, we get 1 minus 2t squared plus t to the power of 4 plus 4t squared. So I'm just running out of space here, so I'll flip the board over shortly. Okay, we can combine some like terms here. So we've got negative 2t squared plus 4t squared. So x is equal to the square root of, and I'm just going to express it with the term with the highest power first. So we've got t to the power of 4 plus 2t squared plus 1. Now notice what's under the surd is in fact a perfect square. So x is equal to the square root of, and I might have to just squeeze it in there. This is t squared plus 1 all squared. And of course, if we take the square root of a square, they cancel, and then you end up with just t squared plus 1. Okay, so actually I'm just going to write it up here. So I'll just write it as 1 plus t squared. Okay, so that goes, and you're left with t squared plus 1, but just for convenience, to make it consistent with the adjacent side, I'm going to call it, just in that order, the 1 plus t squared. Now we can express sine alpha and the cosine of alpha in terms of t, using this triangle. So this triangle is a very, very important diagram to help you sort of understand sort of how this all fits together. So I'm just going to flip the board now. So I'm just going to write what we just came up with before, which is tan of alpha is equal to 2t over 1 minus t squared. You can see it looks like the double angle formula. We've got t plus t, okay, but it's expressed using the half angle instead. And of course, t is equal to tan alpha on 2. Now we can come up with an equation or the half angle representation for sine of alpha. So if we go back to our triangle, okay, so sine of alpha is opposite over hypotenuse, so 2t over 1 plus t squared. And we have cosine of alpha. Again, we go back to our triangle, and it's just good to remind yourself. Okay, so it's adjacent over hypotenuse, so it's going to be 1 minus t squared over 1 plus t squared. Okay, so these formulas, 1, 2, and 3, are our half angle formulae for tan alpha, sine of alpha, and cos of alpha respectively. Thank you for watching.